This is Futurebuilders podcast, and I'm your host, Teemu Uotila. I'm an enthusiastic future explorer working with a Finnish tech company. Together with my guests, we are building the future today. Are you in? This is Futurebuilders podcast with Pasi Vainikka, co-founder and CEO of Solar Foods, a company that creates food out of thin air. Dr. Vainikka is an enthusiastic researcher in energy field. He is also adjunct professor at Lappeenranta University of Technology. Together with him, we will be finding out what are the benefits of producing food without agriculture? How is it possible to produce food out of thin air? Are people ready for these new non-traditional foods? So welcome to Futurebuilders, Pasi. Great to have you here. You're a principal scientist, you were working as principal scientist at VTT, and you hold a Doctor of Science in Chemical Engineering. So can you briefly tell a little bit about your background, how you ended up founding Solar Foods and what you did before that?
Yeah, I used to be, first of all, thanks for having me. I used to be a researcher at the VTT, which is the Technical Research Center of Finland, our national research institute, for some 15 years. My last job there was to lead a single largest renewable energy research program. What we had in the country so far, the name was neocarbon-energy.fi. You find a lot more information there. And the target of that research program was to design an energy system that can be based on 100% renewable energy sources. I think we achieved the target, and there is even the world's first global simulation for fully 100% renewable power system. Visualization of that in the website. So you can drill into any country you want and look at how it works, energy storages and all that included. Now, when you look at that kind of future, which is part of the storyline of building a carbon neutral world, required by the Paris Accord and IPCC and all that, then there are a couple of findings. One is that electricity is the new primary energy, so burning is a bad idea. And then there's about 15% slice in the energy system that you need to, you cannot electrify directly. So how do planes fly and maritime transport and so on, high temperature heat. And for that then we made a pilot plant to demonstrate technology for fuels from air. So producing not electricity from oil, but oil from electricity. So using CO2 as a carbon source. If you leave the fossil carbon in the ground, then you need to recirculate what you have in the atmosphere. And that's kind of done deal in my understanding. The energy system technically can be built. So the rest is political will. But then there was then the question, okay, so far so good, but about 75 to 80% of the greenhouse gas emissions are from energy sector, 25% from what we eat directly or indirectly. So it's not good enough actually to change the whole energy system, but you also need to change how we produce food. Also take into account that we need to produce more food for the increasing population. So then there was the question to my colleagues that can you actually generate edible calories from electricity and CO2? And my colleague at VTT, Juha-Pekka Pitkänen, then had a solution to that. We made a proof of concept for that at the Research Institute. Then based on that, then there was actually interest from the investors to actually an encouragement to set up a company, and here we are.
Yeah. So basically what Solar Food does, it creates protein from thin air, in essence.
That's what we say.
And how does it actually, is it a very complex project or is it simple one? So can anyone basically set up who owns the IP this similar kind of thing? Or?
It's very simple. It is all organic and the most simple and natural way to have food actually. we're just bringing the new harvest to humankind. We're using naturally occurring organisms, so it's fully natural. So what we do technically is that many of the listeners know how beer or wine is made.
Yeah.
So you have a sugars liquid that is a product of agriculture. There is the carbon and energy that a specific yeast can use.
Yeah.
So it eats the sugar and generates alcohol, and grows. Instead of that, our organism that we have extracted from the nature, which is the kind of our magic there, which ones and how you set it up. These organisms you put in the same way in liquid, but instead of sugar, you introduce more bubbles of CO2 and hydrogen. And hydrogen you generate with electricity by splitting water. So that is what you put. Technically, it's gas fermentation. So the freaks know that word. So it's a fermentation, and the microbes can then use hydrogen as an energy source and CO2 as a carbon source and grow. And they are such that their composition is very similar to soy and algae. So they are edible as such. You extract the liquid and dry it, and you end up with a powder similar to wheat flour, or something like that.
So is it carbon neutral in that sense, or does it actually take CO2 out of the system when you produce this?
It's not a thing. So once you eat it, then you breathe it out.
Yeah.
So you are just establishing the circle above ground. So it's not. There are actually a couple of important terms for the more science-oriented people: carbon capture and storage, and carbon capture and utilization, CCS, CCU. And it's very important not to mix this. So we are doing CCU, so this is carbon neutral,
you're
circulating carbon, but it's not really a storage.
Yeah, so it's So in the end, is it sort of like this flour based that is the end product in there, and then you mix it with?
It's a powder. Yeah. There are 3+1 uses for this. It's about 50% protein, 20-25% carbs, and 5 to 10% fat. Very similar to soy and algae, as said.
Yeah.
So how do you use this powder? You can introduce it firstly as an ingredient to existing food and foodstuff. The concept of bread is widely known in the world, so you can actually have higher protein bread, and pastas and shakes and different kinds of new dairy products, plant-based dairy products, let's say yogurts and things like that, where you add plant-based proteins. You could equally supply that, so something what people know, but it's just more environmentally friendly due to the protein source. The second thing is it can also be an ingredient in plant-based meat alternatives. So in Finland we have this nyhtä stuff, so different kind of meat replacements, but Impossible burgers and Beyond Meats. It's a big thing, especially in the US. And still, when you do that kind of texture that feels like meat, still physically you need the calories from somewhere, and they use different kind of protein ingredients. So we can actually be one of the suppliers there. So instead of wheat or soy protein or similar. And then the third is that if cultured meat would be the way to go in the future, when the cells are grown, it's a kind of fermentation process as well, or similar to that, where you have in the growing medium amino acids and sugars plus some others. But the cells need those, so we could actually supply the amino acids to this growth medium. So actually there is we call this, what we do as instead of just producing a powder, it's a platform technology, so we can provide this connection from land
you can use it in
diverse way.
How about the protein composition? Is it more closer to sort of like these meat proteins or vegetable proteins when you look for amino acids?
It's in between.
Okay,
so like soy and algae, it's somewhere there in between.
Okay, so it's there.
Yeah. So if you look at amino acid composition of soy or spirulina, algae superfoods, it's roughly that.
So how much is the calories per 100 gram in this? I mean, can people have a healthy diet if only having this solution available?
It's the same calories and carbs and proteins. They all are about the same. So it's the same.
It's the same. So it doesn't matter. And this is high rich in protein, and to my understanding, at least, protein needs most amount of water in order to be dissected within the human body. So is this a solution also for some areas where you don't have access to clean water, for instance? Does this work in there?
Well, as food, we are not proposing any change in practice into diet.
Yeah.
This is a new type of protein that can replace something existing, less environmentally sound, or provide platform for new growth. So as such, diet is not affected. But what you actually do achieve is more on the production side. So if I remember correctly, 70% from the water use globally is for irrigation, for example, and there are, due to climate change as well, water-stressed areas where you have to have actually quite a lot of effort to produce fresh water, and some of the fossils, groundwater is actually a fossil groundwater. So the production side is where you make the water impact, because we are a closed process. We use 100 or 1,000 times less water compared to something else. So things become very relative once it's closed.
Yeah. So is this product already available? Can people buy it somewhere, or are you still prototyping?
No, what's happening now is we just finished our pilot plant because the world haven't had this kind of food ever before. So we needed to build our own plant that we call a pilot plant. Its capacity is about 1 kilogram per day. And we're almost there with the plant now after a couple of weeks of trials, looking good. And the reason why we do that is that we need to do safety tests for this food. We need to permit as a novel food also in the European Union. It takes 2 years, so we can't sell it. You can. What I can say is that we will provide it for closed sensory testing this spring, but we cannot sell it. And then earliest we could be on the market is 2021, we say. And in which country this happens, then let's see. In Europe, the novel food approval process takes about 2 years from submission. In some countries, it's significantly less. So let's see how it goes, and in which country we come to the market first, and in which capacity.
I'd also imagine that in US the FDA would have also some similar kind of process.
FDA has it. It's a very different kind of process. Seems to be more efficient due to a variety of reasons. And then there are other countries. Of course, Asian countries are important to us. But of course, the European Union seems to be the toughest. So once you have that, you have all the evidence in your pocket.
Everyone else would be easier.
At least you have the evidence once you formulate it to the local for the local administration. So let's see.
What's your sort of like target point? What's your price target here? If it ends up in a store shelves, what would it cost in your mind? If you want to have the optimum.
We aim to match similar to existing. We are not expecting any premium at the end. okay, once you come to the market, there could be some premium for some
not
time.
Such huge volumes.
Yeah,
And stuff.
but once we scale, we don't expect so. So this is actually quite cost efficient, and we're not 10 or 100 times more expensive than the existing. We know that the price level for this kind of ingredient could be around 6 to 7 to 8 to less than 10 euro, 5 to 10 euro or dollars per kilogram on 100% protein basis. So that's kind of the scale we are talking about, and that is what we aim at. So we are not talking about 50 or 500 euros per kilogram.
Yeah, that's definitely a good point. So if you look, for instance, consumers and individuals, do you guys have a plan that you could license this for people so they can do this at home, or does this require a huge plant in order to create this food? So could you have a home kit?
At the moment we see that it would be industrial scale. We are talking about factories that produce couple of percent. For example, if you would build one in Finland, the order of magnitude is such that one plant would produce few percent. Let's say, of course, it can scale up, but from 1 to 5 or plus % of the Finnish protein consumption for food, for example. So that's what we are roughly talking about. And then the plant consumes some tens of megawatts of power. And then, of course, you can scale. What is interesting here is, maybe to finish that. So that is also to say that we are not aiming at home reactors. That would be extraordinary application. And then when you go to market, it's also very different, because then you go to the consumer kind of electronics market, and it's different to the protein ingredient market with the big players.
So if you look then in other use cases, for instance, can this kind of technology be applied for, let's say, International Space Station or
it's actually quite interesting that we do have a project with ESA, European Space Agency, to develop a version of our technology for the Mars missions in flight or at the destination. So what is here different to all the alternatives on the market today is that we are producing food without agriculture. So we don't need arable, fertile land for food production. We can go to the Arctic desert or space. The space application is quite interesting. You have energy there. You can recirculate stuff in the module or at the destination, and even actually one detail in Mars is that the gas atmosphere is CO2, so you're not actually lack of that either. So it's something what we are looking at and to be finished this year. It's very interesting stuff there.
So what kind of partners do you require to do this? Do you partner with your traditional food markets and food producers, or some other technology partners?
What we are not planning to do is to produce food product ourselves. We see that it might be slow way to scale the technology. It would require a lot of effort. Let's see. But instead of that, we're now thinking of at least we need to build the first ones ourselves to prove the case. And after that, it could be licensed for scaling, and to have significant impact, it would be important that there are partners in different continents, that instead of we building and establishing an organization in, let's say, Australia, It might be that there's a partner or an Asian
franchise
partner.
license, yeah.
So that is something what we are. So still, it's we are in the business of turning electricity into enable calories, and we would like to focus on that. And then it could be in a diverse way part of very different kinds of products. So whatever the brand owners want.
Yeah.
And one of the maybe something to highlight here is that regarding scaling and partnering is that it is one of the fundamentals that we think that electricity is the new primary energy, and what we're seeing actually is that the price of electricity or the cost of generation goes down instead of up, and that is very fundamental strategic view that we have, because turning electricity into calories becomes cheaper once the electricity is cheaper. And meanwhile, coming from energy research, we've witnessed that in, let's say, in 5 years, wind power has become the cheapest electricity source in the northern or very southern latitudes, and solar power in the sun belt. So that fundament of using that underlying development now for producing food is something that we follow. The consumer market is then we would like to then provide that with the disconnection from agriculture. So that's kind of how we position now. So, but let's see.
Yeah. For instance, if you look at these renewable energies and solar energy, to my understanding, the pure energy from the sun, actually, it's if you can harvest all that, it's still, it's you can power the whole world with that. So it's a very
we receive energy globally. Is it in 8 hours? Enough to power the world for the whole year. So it's plenty there.
A lot of very very margin that we get out of it currently. So that's definitely good. And so basically, with this solution, you can also tackle, world hunger and famine issues.
Yes, at least the conflict. I mean, the poverty is different. That if food is produced like this, still you would need to have the technology and operations to run it and things like that. So it's. But not to be that black and white. Then maybe the key issue is that there are conflicts. So of climate, population, and food production. So it might be that due to these conflicts, high population in let's say environmentally constrained areas, that might be eased. With this technology, and there's actually quite a lot of interest from the Gulf for this technology. It is understandable because it's all sand, but there's cheap power available. So you could actually make one of the factories in desert. There's no reason for not to do it.
Good amount of solar power and definitely. Being an oil country, for instance, the CO2 is also there.
And what you see also, what our competitors are doing, is that these kind of new proteins could also be provided as feed for animals. So that's one way to disconnect aquaculture, fish farming, or animal farming from the agriculture constraints. That's also interesting option.
Have you done any testing with people? Are they receptive of this, or are they skeptical when you?
So far, it's very positive. I think we're very lucky here to be at this time here, because there has been lots of talk about insects, new proteins, plant-based stuff. And it might have been too freaky to propose something like this to scale 5 years ago, but now it's completely different, and it's good to follow that trend kind of. So it's been positive so far. Let's see.
So basically, your your end message in our listeners would be that the future of this kind of food is coming, and everyone is willing to get on board on that.
In my view, it's very important that we have a lot of especially in the media, frightening news about climate change, and it is very important for people not to feel desperate, but instead the role of engineers on the planet, in my view, is to provide solutions. So it's important that people would be empowered to take part, so that with their decisions the world can be made a better place. So once it's offered, we can offer new kinds of more foods and more sustainable foods. And once they are there, then people then can choose and make their own contribution. So empowering the individual and providing solutions is something what we need to do. And then let's see what happens.
Yeah, that's definitely great. You just listened to Future Builders podcast with Pasi Vainikka, talking about producing food from thin air. To hear more about this fascinating subject, listen to part 2. The future is here tomorrow. Join the discussion on our LinkedIn page, We Are Future Builders, and listen to more Future Builders podcast on wearefuturebuilders.com.